Welcome to Nabeel Math Academy. This is Dr. Mohammed Nabeel. In this video, we are going to see about the horizontal and vertical asymptote. Horizontal and vertical asymptote. What is asymptote first of all? So an asymptote is a straight line which is continuously passing through the curve, but it is not touching the curve at the finite distance. So this is the vertical asymptote and this is the horizontal asymptote. The horizontal asymptote always represent the y equal 1. So here this is the line y equal 1 which is passes through the curve but it is not touching to the curve. So therefore it is a horizontal asymptote. And similarly here we have x equal 1 which passes through this curve. So this is a vertical asymptote. So how will you calculate from the function the horizontal and vertical asymptote here? So the vertical asymptote you can calculate by putting the denominator equals 0. If you solve, you will get the root is real. We will say the vertical asymptote x equals 2 and x equals 3. So upon factoring, you can simplify this part. Now, if you solve this equation, suppose if you get it the denominator like this. Suppose if you have a polynomial function, the rational function x square plus 1 over x square plus x plus 1. When I substitute equals 0, when I solve this equation, you will get a complex root. So therefore, whenever you will have a complex root, therefore we will say there is no vertical asymptote. So vertical asymptote is not exist. So this is a two condition for have the vertical asymptote. Similarly, the horizontal asymptote, we will have some condition. What is that condition? Here we will have the degree. The degree of the numerator is 2. The degree of denominator which is also 2. So depend upon the degree we will discuss. We will have the three cases. Now the numerator degree is more than denominator degree. We will say here it is no horizontal asymptote. When the degree is equal, like the case here, we will have 3x square, here the x square. Therefore, the degree of the denominator and numerator is equal. So, I will take the leading coefficient along with the power. So, you will get 3x square I am taking in the numerator and in the denominator I will take the x square. Now, upon cancelling, you will get y equal 3 is the horizontal asymptote. Similarly, when you have the numerical degree is less than the denominator degree, we will say always the y is equal 0 is the only asymptote, horizontal asymptote. So you will have the three cases in the horizontal asymptote, two cases in the vertical asymptote. Let us solve the problem. Though in the fourth problem, we will get the whole idea about the vertical and horizontal asymptote. Let us start with this problem. So first of all, we will go with this here. So I will solve the vertical asymptote. What do you mean by vertical asymptote? I have to put it the denominator equals 0. So when I substitute x square minus 3x plus 2 is equal 0, you will get x minus 1, x minus 3 upon factoring equals 0. So you will get the value is equal, x is equal 1 and x is equal 2. So this is the vertical asymptote. Now we will take the horizontal asymptote. What is the horizontal asymptote means? So I have to check the degree of the numerator. So degree is 2 here. The degree is 2 and the denominator degree is also 2. So I will take the coefficients. So what happened? Here I will take this part in the numerator. Y is equal 2x square in the numerator, the highest power along with the coefficient, over the highest power of x with the coefficient which is x square. Upon simplifying, you will get y equals to is the horizontal asymptote. Similarly, there is another example we will have here. So what is the another example? So q of x is equal x square plus 3x plus 1 over x square plus 1. Now I have to calculate the vertical asymptote. In order to calculate the vertical asymptote, solve the denominator. Solve the fraction. So fraction function, rational function. So it is equal 0. X square is equal minus 1. When you take the square root, you will get plus or minus 1, which is equal plus or minus I. So it is a complex root. We will say no vertical asymptote for this. So there is no vertical asymptote. Why? We are getting the complex root upon solving the denominator. Similarly, here the horizontal asymptote, I will take the highest power in the numerator, which is equal x square. Y is equal x square in the numerator, x square in the denominator. Upon cancelling, we will get 1. So y equal 1 is the horizontal asymptote. Horizontal asymptote. Now, we will take this one again. The next problem in which we will have a degree is less. So numerator degree is 1, denominator degree is 2. Let us solve this problem. So first of all, we will calculate the vertical asymptote. In order to calculate the vertical asymptote, I have to solve the denominator. What happened here? X square plus 5x plus 6 is equal 0. Upon simplifying the factoring, x plus 2, x plus 3 is equal 0. X is equals minus 2, x equals minus 3. Therefore, you will have these are the vertical asymptote. Now, let us go with the horizontal asymptote. In the horizontal asymptote, the degree of the numerator, it is 1. The degree of the denominator, which is 2. Therefore, which is more. So, I write it this one. Degree in the numerator is less than degree in denominator. So what are the condition? We will take it here. Let us go in up. We will see. So in the degree of the numerator less than degree of denominator, therefore there is only one possible asymptote, which is equal y equals 0. For all the problem, this is true. Now the last problem, g of x is given by x square plus 5x plus 6 over x plus 1. So in order to calculate the vertical asymptote, just put it equal 0. X plus 1 is equal 0. X is equal minus 1. So this is the vertical asymptote. In order to calculate the horizontal asymptote, I have to check the degree. So what are the degree here? The degree is 2 in the numerator. The degree is 1 in the denominator. So I will write it here. Numerator degree in the numerator is more than degree in the denominator. Degree in the denominator. What we say here? Degree in the denominator. So as per this rule, so when you have the numerator degree more than denominator degree, no horizontal asymptote. So I will write it no horizontal asymptote. So within the 4 problem, we will discuss all the different condition. Thank you.